This is Algebra 1 spring test for week number 6, part 2, picking up at number 13. It says a line passes through 2 points, 5, 1, and 7, 10. Write an equation for the line in point slope form. You need two things to make point slope form. You need a point, which we have two of them, and you need a slope, which we don't have it yet. We have to find what the slope is. So you need to take those 2 points, 5, 1, and 7, 10, and you need to find or calculate the slope from it. Your slope formula is the change of y, so y sub 2 minus y sub 1, over the change of x sub 2 minus x sub 1. So you label these 2 points. The first one's going to be xy for the second one as well. It's always x comma y in alphabetical order. We'll call the first point sub 1, and we'll call the second point sub 2. So if you plug those points in where they belong, or you plug each of those values in where they belong, the first one asks you for y sub 2, that's 10. Minus, then it asks you for y sub 1, which is 1, over x sub 2's value, which is 7, minus x sub 1, which is 5. 10 minus 1 is 9, and 7 minus 5 is 2. So your slope of the equation is going to be 9 over 2. Again, it tells you to write it in point slope form. Now we have a point and we have a slope. Point slope form is y minus y sub 1 equals m, or the slope, times x minus x sub 1. You leave y alone, you leave the equals, and you leave a set of parentheses with the first x, and you plug in the rest of the values. Take one of the points. We'll go with the first one, 5, 1. Let me write it in a different color. Take one of those points, 5, 1, and plug in each of those values where they belong. Where y sub 1 goes, you use the y value. But whatever it says, remember, you use the opposite of what it says, since it says minus. It says 1, so you put in negative 1. The m value is the one we just found, which is 9 over 2. And where it says x, you plug in the opposite of what it says, since it says x minus x sub 1. It says 5, so we're going to put in negative 5. There you are in point slope form. Y minus 1 equals 9 over 2 times x minus 5. If you use the other point, 7, 10, instead of 5, 1, you could still make point slope form. Instead, it'll say y minus 10 instead of y minus 1. It'll still say equals negative 9. It'll still say equals 9 over 2, but it'll be times x minus 7 instead of x minus 5. So that's the first part, is to write it in point slope form. The second part tells you to rewrite it in standard form. Remember what standard form is. It's ax plus by equals c. But it says using only integers, or using integers, no fractions. So the first thing you want to do is you want to eliminate the fact that it says 9 divided by 2. You want to eliminate that fraction. In order to eliminate divide by 2, we know we need to multiply that term by 2. If you multiply that one, you have to multiply everything else by 2 as well. You have to multiply the entire fraction, the entire equation. 2 times y will be 2y. 2 times negative 1 is negative 2. It cancels this one out and just leaves you with 9 times x minus 5. So when we simplify that, 9 times x is 9x. 9 times negative 5, not times 5, but negative 5 is negative 45. It's still equal to what's on the left side, 2y minus 2. But it doesn't quite say standard form yet. It doesn't quite say ax plus by equals c. We have to move a couple of things in the equation. We do know that if we move over 9x from the left side, from the right side to the left, it was positive. It becomes negative 9x. 2y we want to leave where it is, since it says ax plus by equals c. But it doesn't say that minus something equals c, which is equals negative 45. We have to move that negative 2 over to the right side. If you in order to do that, you add 2 to both sides. So you have negative 9x plus 2y equals, when you add 2 to both sides, you get negative 43 on the right. Ax plus by equals c. If you don't change your a value from a negative to a positive, we'll leave it as a negative for now. Negative 9x plus 2y equals negative 43. So that's the second part, writing it in standard form. 14 asks, are the graphs parallel? This goes back to 1, 2, and 3 on a study guide, where it asks you one solution, no solution, or infinitely many solutions. Parallel lines have no solutions. They don't intersect. Without having to graph these equations, though, you don't have to draw pictures to see them. We know parallel lines when we graph them. We know they're going to look like this, and they're never going to intersect each other. They'll never get closer or farther apart. But we don't have pictures to look at when we're looking at these two equations. We just have values. Parallel lines have the same slope. If you don't know that parallel lines have the same slope, you need to say that to yourself 100 times tonight the way you remember it for tomorrow. Parallel lines have the same slope. The first equation says y equals 6x plus 1. Y equals mx plus b. The m value of that first equation is 6. Its slope is 6. Remember, m looks like two little mountain peaks or two little mountain slopes. 6. The other equation, you can't quite see the slope as easy. We have to transform it. We have to move that equation. So you have negative 7x plus y equals negative 7. We wanted to say y equals mx plus b. We don't quite have that. We need to move this negative 7x over to the other side. If we do that, we have y equals, it was negative 7x on the left. It becomes positive 7x on the right. And you don't move negative 7, so it's written that way. Now it says y equals mx plus b. So you can see the m value is 7. You can see what its slope is. Again, parallel lines have the same slope. Are these lines parallel? 1 is 6 and 1 is 7. Those are not the same value, so no. Where it tells you to explain it, different slopes. It's like different strokes. (15 and 16), we solving these using elimination. First thing you got to do to check to see if you can eliminate by combining. Remember, elimination and combination are the same way to describe this method. You have to make sure your x's are on top of your x's. We got that. X's are good. Y's are on top of y's. Equals are in line. Constants on top of constants. We're good for all of those things. So everything's lined up nice and neat. Then you have to check and see if you have opposite coefficients. Remember, opposites are numbers like 3 and negative 3, 100 and negative 100. Opposite sign, the opposite term, not just the opposite sign. 6 and negative 8 are not opposite just because one's positive and one's negative. It has to be one positive, one negative, and it has to be the same number. So right here, if you look at your x terms, you have 5x and 5x. It's the same number, but not opposite signs. If you look at 5y and negative 5y, those are your opposite coefficients. That makes it to where you can eliminate the y variable at first. When you combine them, 5x combined with 5x gives you 10x. 5y combined with negative 5y gives you 0y. Going to write that as just a placeholder. There's no reason to write it in. And 0 combined with negative 50 is negative 50. So what you're left with is 10x equals negative 50. And in order to get x by itself, you divide by 10 since it says 10 times x. Divide the right-hand side by 10 as well. X equals negative 5. There's your first value for x. Take that value, negative 5, and in place of x in one of the first equations, we'll just use the first one, plug it in. So instead of 5 times x, 5 times negative 5 plus 5y equals 0. 5 times 5 is negative 25 plus 5y equals 0. Get rid of minus or negative 25 by adding it to both sides. And 5y equals 25. And in order to get y by itself, divide by 5. So y is 5. So you have x equals negative 5, y equals 5. X comma y, negative 5 comma 5, written as an ordered pair. Number 16 is lined up as well. X is on top of x's, y's, equals, and constants. Everything's on top of each other. But you don't have opposite terms. You have 3x and you have 1x. You got negative 4y and you got 1y. So we can either multiply the 1x at the bottom by something to make it the opposite of 3, or we can multiply the 1y at the bottom by something to make it the opposite of negative 4. Both of them are about the same. It's easier to multiply by 3 than it is by 4. So we'll multiply this bottom equation to make this x, or this 1x, turn into the opposite of 3x, which means we want that to be negative 3x. So multiply that term by negative 3. If you multiply that by negative 3, however, you have to multiply that whole equation by negative 3. So that one and that one as well. You have to distribute negative 3 to everything. So what you have now is negative 3 times 1x is negative 3x. Negative 3 times y is minus 3y. And negative 3 times a negative 1, negative times a negative is a positive 3. So that's that bottom equation converted. The top equation can stay just like it is. 3x minus 4y, I'm just writing it underneath it, equals negative 24. Now when you look at your two equations, again, they're stacked in a proper spot. Now you have opposite terms. The first two, x negative 3x and positive 3x. When we put those two together, it eliminates those to combine them. Negative 3y and negative 4y, when you combine them, is negative 7y. And 3 and negative 24, when you combine those, is negative 21. So you have negative 7y equals negative 21. Get rid of that by dividing by negative 7. Do it here as well. A negative divided by negative is a positive. So now you have y's value of 3. Plug y equals 3 into either of the first equations. The second equation looks easier because there's no other numbers that go along with x and y. So in that equation, instead of x plus y, we'll have x plus y, which is 3, equals negative 1. So x plus 3, undo that by subtracting 3 on both sides. X equals negative 4. X comma y, negative 4, comma 3. Number 17 and 18, again, we use an elimination. Look for number 17. Nothing's in the correct order. So we have to change one of them to make it match the other one. We'll leave it in the same form as the one on top, just to keep it simple. So the first equation says 4x equals negative 21 plus 5y. Let's move everything over. So we still want the equals to be right there. We still have 45 right next to it. We're not going to move that one. We're going to leave it alone. But we're going to swap the x and the y values to make them be line up in the right spot. 5x, we want to move it to the opposite side. It was positive on the right. It becomes negative 5x on the left. 10y, we want to move that one to the other side as well. It was positive 10y. It becomes negative 10y. Now everything's stacked correctly. So you have to make a set of opposite coefficients. You can make 4 and negative 5 turn into 20 and negative 20, or you can make 5 and negative 10 turn into 10 and negative 10. That's the better one. That's the better way to go, because you already have one as negative 10. So what we want to do is we want to multiply this 5 by whatever number we can to make it the opposite of negative 10. The opposite of negative 10 is 10. So we want to multiply that 5 by 2. We want to distribute, in fact, this entire equation by 2. So 2 times 4x is 8x, equals 2 times negative 21 is negative 42. And then 2 times that 5y, which we was doing originally, is plus 10y. Now you have two equations that are stacked correctly with opposite coefficients for the y value. Negative 10y and positive 10y combined is no more y's. They eliminated. That's what we were doing. Negative 5x and 8x gives you 3x. And 45 and negative 42 gives you positive 3. In order to find out what x is, now divide 3 on both sides. X equals 1. Plug x equals 1 back into one of the other equations. We'll use the first one. 4 times x, or 4 times 1, equals negative 21 plus 5y. So 4 equals negative 21 plus 5y. When you get rid of negative 21, you add it to both sides. Plus 21 on the right, plus 21 on the left gives you 25 equals 5y. And then when you divide by 5 on both sides, y equals 5. X comma y, 1 comma 5. Number 18, the same thing, except these are nice and neat stacked up for us. X is on top of X's, Y is on top of Y's, constants on top of constants. And we have, on top of that, we have opposite terms, 3x and negative 3x. Those cancel out and eliminate. Negative 4 and positive 2y give you negative 2y. And then 9 and 9 give you 18 when you combine them. When you divide by negative 2 on both sides, you get y equals a positive divided by negative is a negative 9. Plug that back into one of the other equations, 3x minus 4 times our new value for y, which is negative 9, equals 9. Negative times a negative is a positive 36. So 3x plus 36 equals 9. When you subtract 36 on both sides, 3x equals 27. And when you divide by 3 on both sides, you get x's value as 9. So now you have x and you have y. X comma y 9 comma negative 9. And then the last equation question says, by what number should you multiply the first equation to solve using elimination? The way you solve this one is you look at your factors of 5 and 10, and you look at your factors of 2 and 3. The first number that 2 and 3 goes into is 6. So we would have to multiply both equations in order to eliminate y using 2 and 3. However, for the x's, the first number that 5 and 10 goes into is 10. So you don't have to change the bottom number at all. You simply have to change the top x to become the opposite of the fact that it says negative 10 here. So you want the top x to become positive 10x. So what do you have to multiply negative 5 by to get it to become positive 10? You multiply it by negative 2. So you multiply the entire first equation by negative 2. That'll give you positive 10x. That'll give you positive 4y. And it'll give you negative 70. So that's what that equation will look like. However, the question only asks you, by what number should you multiply the first equation to solve? Negative 2 is the correct answer for 19.